Hi students, today I am with the second video regarding the completion of first model of atom, that is J.J. Thomson's model of atom. Lastly, we read about one of the postulate of J.J. Thomson's model of atom, and according to that we got aware that the atom is spherical in shape and there is uniform distribution of that very positive charge and there are negative charges embedded in it. And this model is also known as the plum pudding model or the watermelon model. You might have seen, my dear watermelon, the redness in that very watermelon is taken as the positive charge because that is uniformly distributed in that very watermelon. And there are seeds in the watermelon. Those seeds, in order to understand the model, those seeds are taken as the negative charge. And that you have to understand how the model is about. Now today we are going to read about the rest of the postulates of this model. And the second of the postulate is that each atom consists of negatively charged particles called electrons. So from this very model we got aware that it is the negative charges in the form of electrons. So the negative charge present in the atom is in the form of electrons. And then we are having another postulate regarding this very model, and that very postulate is that as atom is wholly and solely neutral, so the negative charge negative charge and positive charge must be equal. As we are aware that the atom is wholly and solely neutral, it doesn't have any net charge. So definitely, as now wherever there is positive charge, wherever there is negative charge in the form of electrons, definitely the total electron charge must be definitely equal to the total positive charge present in the atom. And moreover, there was another postulate regarding this, and the postulate was that the harmonic oscillations harmonic oscillations of electrons about their mean position about their main position are responsible for emission of light. So this postulate is regarding that there are harmonic oscillations, that is the electron is moving to and fro, motions that is showing about its mean position for the emission of light. And another postulate that was that Thomson predicted that alpha alpha particles passing through the atom only suffer small deflections. What was it? That alpha particles having the positive charge, alpha particles having the positive charge, and he was of the idea that once this very alpha particle is allowed to pass through an atom, they only suffer small deflections. But these were the postulates of this very model. But this very model was having few drawbacks. The drawbacks of this very model, drawbacks of J.J. Thomson model. The first of the drawback was that it could not explain, it could not explain discrete discrete spectral lines, discrete spectral lines emitted by hydrogen and other atoms. So it was one of the drawback that it could not explain the discrete spectral lines. Regarding this very spectral lines and discrete one, we have to read in the coming lectures. But right now, it could not explain the discrete spectral lines emitted by hydrogen and other atoms. You might have heard somewhere the continuous. The spectrum of hydrogen atom at that very time was found to be discrete, not continuous. So it could not explain that very discrete spectral lines. Like you might have heard somewhere Lyman series, Balmer series, Postgen series, Brackett series. So it could not explain those very series. He was of the idea that there should have been a continuous spectrum, but fortunately or unfortunately the spectrum was discrete one. Secondly, his model his model could not explain could not explain large deflection of alpha particles. Large deflection of alpha particles, which was proved by Rutherford. So it was one of the these were the one of the biggest these very drawbacks of J.J. Thomson's model of atom, that it could not explain the discrete spectral line series. He was of the idea that there should have been a continuous one. And secondly, he could not explain the large deflection of alpha particles, which was proved by Rutherford later on. There is large deflection of some of the alpha particles which are having the positive charge. So dear, we're gonna this is the completion of this very first topic. After tomorrow we're gonna have a new topic regarding the alpha particle scattering experiment by Rutherford, who gave us the concept of actually nuclear concept of the, the nucleus that came into the concept. That was only after the Rutherford's experiment. Before that there was no concept of nucleus. Although there is concept of positive charge, there is concept of negative charge in J.J. Thomson's model, but there is not the concept of what I mean to say, nucleus. Okay, Allah Hafiz. Tomorrow we will having a new video regarding alpha particle scattering experiment.